This is a statue of Hypatia in the Crow Amphitheater at the Hockaday School. Hypatia was a philosopher, a mathematician, a teacher, and an astronomer. On the sculpture, we have the different astrology signs, so Aquarius, Gemini. All of the zodiac constellations lie along the ecliptic, which is the circular path of the sun across the sky. All of these constellations can help determine the seasons and the time of year. Here on the statue, you can see we have an outer circle surrounding Hypatia, and engraved in the statue is the number of degrees. There's a total of 360 degrees in a circle, and they're being counted by 5. So if there's 360 degrees in a circle and they're counted by 5, how many sections of 5 degrees are there? I'll give you a second to think. There's 72. You divide the circle into sections of 30 degrees. How many would there be? There would be 12, because 12 times 30 is 360. So there's so many ways that you can divide a circle depending on how many degrees you want to divide it by. You can also form right triangles in a circle. You can cut the circle up and make many different triangles to find out the angles of each triangle using what you know about a circle. Why don't we now find the circumference of the outer circle? The formula for the circumference of the circle is diameter times pi. I can use my measuring stick here to find the diameter. Or I can always find the radius of the circle and multiply it by 2. If I take my measuring stick from one end of the circle to the other end, we can see that the diameter is about 73 inches. Therefore, the circumference of the circle is 73 pi. Now we can compare the circumference or the area of the inner circle compared to the outer circle. When we found that the diameter of the larger circle was 73 inches, we can look at the diameter of the smaller circle, 45 inches. If we create a ratio of 45 to about 73, that's about a little less than 2/3. So the circumference of the circle is about 2/3 the circumference of the larger circle. Here I am on Hockaday campus at a circle drive used for carpool. As you can see, we have these traffic bollards. They were at least 5 feet apart to ensure that a car will not get through. You might just walk past them every day thinking, they're just traffic bollards, what more to them? But actually, there's mathematics in the traffic bollards. Why do you think that they are all a cylinder shape? No edges, pleasing to the eye? Well, actually, this cylindrical shape provides the maximum stiffness with the minimum amount of material. I'm here in the Crow Amphitheater at Hockaday, and today I'm going to ask you about slope. You can see there's many different slopes, such as the steps of the amphitheater, smaller steps along the sides of the amphitheater, and even the railings. I pose a question to you. Which slope do you think is the steepest? Actually, all have the same slope. So how do we know that? How can we find that out? We can also find that out through mathematics. We can also measure and find the slope of each. Using our tape measure, we found that each step of the stone for the amphitheater is 66 inches in length by 22 inches in height. Now, since the slope of the amphitheater steps is equal to the steps on the side of the amphitheater, we can find a proportion. If there is 3 vertical distances, that has to equal about 22. Each step height is a little over 7 inches. Distances in length has to equal 66. So each step is a little bit over 15 inches as well. What is the purpose of slope in an amphitheater? Well, if you have people sitting on each step, the slope should be gradual, and you should also have at least 4 feet in between each step so that people can sit in between.